I really wanted to get these spark plugs out. So, I made my own socket. Well, I modified one. The one on the right here is about what this one looked like when I started. I took off probably about 3/8 of an inch off the bottom, and then about an 1/8 inch off the top. Ground the high points around the edge here, and then took the die grinder and cleaned up the chamfer, or cleaned up the inner edges of the socket where the spark plug actually goes in, make it a little bit easier so you can get a little off alignment. And then also drilled out the center to a fairly large drill bit size, just slightly larger than the 3/8 hole that's, or this 3/8 square for the socket. And then just chamfered up the corners up here. Now this, cutting it down to both ends is what really let it fit. That and the drilling a hole that lets the tip of the spark plug pivot inside a bit. And I managed to get both number 2 and number 4 out. So now I've got a custom header spark plug removal tool for the GT40P with turbo manifold. Cool. Okay. New plugs are in. Speeduino seems to be working. I'm going to do a quick cycle of the key to make sure everything's plugged in. I'm going to see if it does anything. Wish me luck. Future me here, and I'm here to tell you, I took about 2.5 hours, maybe even more, probably closer to 3, of diagnosing and trying to figure out what the hell was going on here. So the Speeduino has a jumper in it. You can switch between 5 volts and 12 volts. 5 volts letting you set up the Arduino and flash the firmware in it while you're connected to a USB power, 5 volts. When you're done with that, you switch it to 12 volts power, and then in my mind, it should only work under 12 volts. However, when I had the computer plugged into the Speeduino, the ECU would stay energized. At least it would stay energized enough that it would let me have full communication with the ECU. I could flash, I could make changes to the tune, I could do everything I wanted to do as if it was powered up. Then, on top of that, I had a strange issue where I constantly had 12 volt positive on both sides of the fuel injectors. I come to find out after a little bit of internet digging and searching that is normal with a Megasquirt Speeduino ECU. When the ECU is energized, you will have 12 volts on both sides. Unlike an OEM ECU that I'm used to, where the ECU side, the switched side of the fuel injector, will not have 12 volts. But anyway, I went ahead and did a few more testing with the original ignition coils. Could not get any spark out of this system. And then going back to the power issue, I would key off, and even after unplugging the USB, I would still have power to the fuel injectors on both sides of the terminal. I could not, for the life of me, figure out what was going on for, like I said, a few hours. And we'll jump here in a moment to show you what I ended up finding and how I fixed it, which is kind of dumb that I had to do it in the first place. But that's solved, and it's time to keep on rolling through this. So I got something for you now. I was still having the issue where the ECU wouldn't power down, and I was getting constant 12 volts. I pulled the blower motor relay, swapped it with the ECU relay, still did the same thing. Grabbed just a random old relay from like a fog light kit or something that I had kicking around, and now it seems to work. So if I go key on, You get 12 volts at the fuel injector. Fuel pump runs, ECU's priming the system. Get a key off. There goes click. The relay turns off. The power goes away. If I pull this out, I'm curious if it's going to change behavior. Now this is the original Ford relay. You see we're at 0 volts. Key on. 12 volts. Shut up. Alright. Key off. And we maintain. So there must be some kind of diode or resistor pack inside these relays that go bad and short. And that was causing the issue the whole time of the ECUs. Yeah, see if I cut the key right there? Instant. The, whatever's controlling this relay instantly cuts power, ECU shuts down. So, at least I got that figured out. Just kind of sucks that I can't run an OEM ECU, well, duh, an OEM relay, because these are, I got a bunch of these, so. Now, I guess I can continue on diagnosing why this thing isn't firing the ignition system. One piece at a time. So I did a bunch of digging, a little bit of reading. Come to find out that the EEC5 ECUs have the igniters built into the ECU, not in the coils. So these are in fact dumb coils. And it's the same thing with all EEC5 ECUs and coil setups. So it's real unfortunate that the Speeduino will not work with these factory coils. I should have listened to my buddy when he said just put a distributor on it. But I was stubborn. So the options that I have is go with another OEM 4-channel igniter. And I don't have any, but I did manage to dig up some of these 1UZ igniters, and these should be 2 channels each. But I don't think, these have been sitting outside for a while. I don't know if they're any good anymore. But the alternative is like the DIY Autotune 4-channel igniter for $100, $110, and that seems like it's a good option. Other than that, I'm kind of SOL for this setup. There's just not anything else I can do other than put in igniters. So the solution to these being dumb coils was to order smart coils. These are actually for a VW. Apparently they came on a shit ton of them, so they are readily available. And I was able to source the connectors with new pins. So the challenge is mounting these things, and none of the bolt pattern is just completely wrong. So I thought about maybe welding a little spacer in between the body here of the coil and the bracket, but I don't have any bolts long enough, and I don't feel like waiting. So I'm going to use all thread and just go down like that. This is M6. Weld it to the body and just put a nut on top. So then I won't have to worry about drilling and trying to tap or do anything like extreme to this bracket. It'll just be as simple as welding those studs. Got her done with a little bit of tweaking with a hammer. The studs are pretty smooth. And top her off with a stainless steel flange nut. Now for the easy part, the wiring. On these connectors, they've got numbers to label the pins. So you can see there 1 through 4. So in this, for these coils, number 1 is going to be one of the signals. Number 2 is going to be a 12-volt positive. 3 is going to be the second signal, and 4 is ground. So within this harness, we've got 3 of those wires already. So the only wire we have to add is a ground, and I've got these M8 ring terminals. So I'm going to take that plus some 18 gauge wire and make a little ground. Probably like, the coil sits up high, so it's probably going to be like 10 inches or so, and I'm going to ground it right to the mounting post that the coil mounts to. I already did a continuity test, and I do have ground there, which makes sense because it's going into the engine. But it was just a trust but verify situation. So these are pretty easy. There's wrappers that'll do these. I'm going to use my big boy crimpers because that's what I've got handy. Alright, so that's one. Just like all the other terminals, 1/8 inch, maybe a little bit longer than an 1/8 inch. And we want to set the terminal in like that so the 2 flags up on the front here actually bite into the copper. Now these terminals are a little too big for this, but it'll work just fine. So yeah, that's good right there. And I'm going to flip these around and do the second flat set of flags here. This is just what secures the insulation. And there we go. Got a good ground to use. So I just got that second one whipped up. And this is no different than any other of the connectors that I've shown so far as the methodology. It's just the terminals are a little different. So these are a very typical Bosch style terminal where these little tabs are on the sides, these little tangs or tabs, flanges, whatever you want to call them, that's with the retaining piece. So when these get pushed in to the terminal housing, they land in those voids on the top and bottom. And the only way to get these out is to have the proper tool. And it basically is like a fork, and it pushes in on the top and bottom around the center of the terminal here, and then pushes those tangs down and lets the wire terminal come out of the housing. So if you don't have that tool, it's a royal pain in the ass to get these out. The 7M throttle position sensors had these terminals from the factory, and let me tell you, it's better to just replace the whole damn thing. Alright, so I'm going to go ahead and run through one of these, and then the rest of that I'm going to show you how to depin those forward connectors, and then I'm just going to run through this, finish her out. So we got that stripped, about 1/8 inch. And just put the wire seal on while I'm putting on, I'm twisting. And then just like everything else, and you'll see that these terminals have a little, like a boss. It's bulged on the end here, and that's to accommodate the wire seal. So that way, once it's all crimped together, the terminal doesn't bend in an odd manner. So we're going to start with this one right here. feel better going a little smaller. Let's do the 2.0. Yeah, that's it right there. Okay. So we know from our little diagram here on pin 4 is ground. So I'm going to go ahead and insert this, and just like I said before, these little flags, they need to align to the top and bottom cavities. So this tag or flange, English, this tab needs to face up and down when you're slipping these terminals in. Right there, it's clicked, and you can just see the lips of the terminal there. So you're seeing that in the front, and just like that, got a little ground strap for the smart coils. All right, I'm gonna try to stay in focus here and stay in the center of the screen, but no guarantees. I need some tools. So I'm probably going to bump you a few times, so if you shake a little bit, sorry about that. So this is like some of the other connectors we have seen. It's got this red lock that prevents you from depinning. So typically there's like a little lift point. Looks like... Oh. Okay. So back at it. I'm going to come in this side right here. You can see it's coming up pretty easily. And that comes out. And then now we can zoom in and we see the little tangs or tabs that are holding these in. They're right there, there, and there. Go ahead and pull this harness back a bit, or this loom. That way I can get a purchase on one of these wires. Alright, so as I'm pushing in, this one basically just fell out. Let's see, the seal is integral to the housing. A little different than the connector we're putting on. Kind of similar receiving end there, but definitely different. So I'm going to, so I know this is my 12 volt power. So I'm going to go ahead and take that one, and I know this is my signal 1. So I'm going to go ahead and put the new terminal on this wire. That way I do one at a time and I don't get these mixed up. Yeah, I've got access to the book, so it wouldn't be the end of the world, but good practice, it's a good habit to get in, is just do these one at a time, unless you're familiar enough with it where you know all the colors offhand. So just like the other sensor connectors that we've done, I'm going to cut off and retain as much of the wire as possible. So cutting off just behind the actual crimp. That's going to leave that little bit there, which the auto crimper should make easy work of. This wire's about that. Perfect. I'll get a wire seal on and a terminal, just like the ground. Oh, helps if I'm in frame. Sorry about that. I'm at an awkward angle here. Okay, so we know we've got signal 1 and signal 2. Now, I'm willing to bet pin 1 is signal 1, and pin 2 is, or pin 3 is the signal 2. This wire would be our signal 2, red with a blue stripe. So I'm gonna just take a well, not take, but I'm gonna go out on a limb here and just go ahead and put that in that terminal. Now, like I said, if this is wrong, these are kind of a pain in the ass unless you have the tool, and it's something like this. It's one of these universal kits will have, most likely have it. So if I do end up finding that this is the wrong channel, then I'll have to depin and swap it around. So that's the process here. I'm just going to quickly keep on buzzing through this. I'm going to do the 12 volt positive next, and that's going to be our pin 2. And just like that, we've got a completed VW coil connector with ground. So there's one last step that I didn't realize on these connectors, and I'm glad I did, because if you try to install this, see, it doesn't want to go, and it's because of this lock. So if you peer in the top here, you can see that lock needs to be pushed in real easy. But if you didn't know that and you went ahead and forced it, you may cause some damage. Oh yeah, that's satisfying. Let's see, is this... How does this one work? So it should be a push down. I hate these connectors. Yeah, okay. What a pain in the ass. That was tough. Okay, cool. I'm ready to test those channels. So I've got my number 1 spark plug lead plugged in, and just the spark plug chilling up here. Probably should have it not directly on, should probably not have it directly on the igniters. Alright, so in Tunerstuido, you have to enable it, but there's a hardware testing window, and I've just turned it on here, enable test mode. So what this will let you do is test individual outputs of fuel injectors up top and coils on the bottom, but you don't want to ever use the on if you have the injector plugged in directly, because that'll just send a constant 12 volt signal to fire the coil, and it will burn them up. And you want to be careful. You don't want to have your fuel injectors plugged in if you're testing the fuel injector outputs. So I've got spark plug lead number 1 here. Got the spark plug resting on a ground, and I'm testing that my channel 1 is in fact these 2 posts, and I don't think it will be, because the first pin is on that side of the bank, so that's just my assumption. So we're gonna figure that out, and if it is on that side, then I think I'm gonna go ahead and just swap those pins. So if we perform this test and it doesn't work, then we'll know. So I'm going to click the 50%. And I hear it clicking, but I don't see a spark. Go back here and do off. Let's do channel 2. Yep, there's a spark. Okay, so that confirms it. So I'm going to click off, stop test mode. Okay. So now I know this is channel 1 on these, or this is pin 1, and this is pin 2. So the layout of this is going to be Pin 1 is our signal 2. Pin 3 is our signal 1. I'm going to go ahead and depin those real quick. Okay. Coils are done. I think the firing order's right. It is 12:30 in the morning, so I have to hear this thing at least sputter. At least sputter.